In this topic, we'll map out how Luna HSMs are put together and how you actually use them. You'll see how appliances, partitions, roles, and security domains connect, and how they deliver isolation and high availability for your applications. You already know what an HSM is and why Luna matters in an enterprise. Now we'll zoom into its architecture: partitions, roles, security domains, and isolation. Once that mental model is clear, we'll move on to installing clients and establishing secure partition access. Luna's architecture is layered to keep keys safe while still being easy to consume. At the foundation, the physical HSM is a hardened appliance that stores keys and runs cryptographic operations inside a tamper-resistant boundary. That hardware is carved into isolated partitions, each assigned to a tenant or application. Client systems connect securely to those partitions, and applications simply call standard APIs like PKCS number 11 or Java providers to use the keys. A Luna HSM appliance is a purpose-built security box, not just another rack server. At its core is a crypto processor and secure key storage, forming the protected boundary where keys are generated and kept. Network interfaces are how applications and admins securely reach that boundary. Firmware and policy logic decide which algorithms, key sizes, and operations are allowed. Management services then handle configuration, monitoring, backup, and day-to-day administration. Think of a partition as your own locked room inside the HSM. The hardware is shared, but each partition behaves like a separate, dedicated HSM. Keys created in one partition can't be seen or used in another. Policies on that partition decide which operations are allowed and how applications interact with their keys. In PKCS number 11 terms, think of a slot as a doorway your application can walk through. Behind that doorway is a token, which is the key store exposed by the HSM. On Luna, that token usually maps to a specific partition. So the chain is: application chooses a slot, which selects a token, which reaches a partition. If those mappings are wrong, you'll open the wrong partition, or see no keys at all. Another way to picture it: a Luna HSM is a secure apartment building and each partition is a separate unit. Payments, code signing, and PKI services each get their own unit, with their own keys and admins. They share the same hardware, power, and monitoring, but can't see into each other's space. That isolation lets security teams centralize infrastructure, cut costs, and still give each team clear ownership and control over its cryptographic environment. Luna HSMs protect keys using layered isolation. First, the physical boundary and tamper resistance make it hard to open or probe the device without destroying secrets. Inside that, partitions keep different applications and tenants from ever seeing each other's keys. Role-based access then controls who can initialize, manage, or use those partitions. Finally, partition policies restrict which algorithms, key usages, and operations are even possible, enforcing least privilege by design. Luna clearly separates people who run the box from people who use the keys. The security officer handles appliance setup, network configuration, and firmware. The partition owner defines policies, assigns roles, and manages backups inside a partition. As a developer, you mostly live as a crypto user. Your job is to authenticate the application, obtain the right credentials, and call the HSM to sign, encrypt, or decrypt, without gaining broader administrative power. Luna gives you two main authentication models, and each changes how you build and operate the system. PED keys provide the highest assurance because a physical device and usually a person must be present. That's ideal for tightly controlled HSMs, but it makes automation and remote workflows harder. Password-based authentication lowers assurance somewhat, but is easier for scripts, CI/CD pipelines, elastic scaling, and hands-off operations. A security domain is basically a club that HSM partitions either belong to or don't. If two partitions share the same domain, they're allowed to exchange encrypted key blobs for backup, restore, or cloning. If they're in different domains, that movement is cryptographically blocked. This matters for disaster recovery, migrations, and high availability, because you must plan partitions and appliances so critical keys all reside in compatible security domains. Before you integrate with a partition, treat policies as part of your API contract. First, Verify which operations each key type is allowed to perform. Don't assume encrypt implies decrypt or sign. Next, check whether keys can ever leave the partition, even wrapped. Confirm how backup, cloning, or migration are supposed to work. Finally, validate that your application's roles and credentials actually match those policy assumptions. High availability is about hiding individual HSM failures from the application. Instead of talking to a specific partition, the application connects to a logical HA group. That group knows about multiple HSM members and decides where each request goes. If the primary member fails, traffic is redirected to another member and can also be load balanced. This only works well if keys, security domains, and synchronization are planned, and if the application retries intelligently. Scalability with HSMs is a balance of design choices, not just buying bigger boxes. Session pooling trades a bit of complexity for much lower connection overhead, so watch active versus idle sessions. Network latency directly adds cost to every crypto call. Track round-trip time under load. High availability and key synchronization improve resilience, but only if replication delay stays low enough that failover nodes always have the keys you expect. You've now seen how Luna HSMs provide secure hardware, isolated partitions, and role-based control, all wrapped in policies and security domains. You've also met the HA and scalability concepts your applications must respect. Next, we'll install Luna Client, build trust, authenticate, and actually connect to partitions.